So here's an example that we first saw in the video where I introduced the concept of elasticity. And it was the same market starting at the same point, price of $10, selling 500 for a total revenue of 5,000. And we showed that with the same price increase from $10 to $12, depending on how much quantity demanded fell, our revenue could actually fall from 5,000 to 3,600, or it could go up from 5,000 to 5,400. And we talked about the fact that it was elasticity that told us what would happen, told us what was bigger, the percent change in quantity or the percent change in price. So told us what would happen to total revenue as we changed our price. And then we talked about in the next video about how if elasticity is greater than 1, that's saying the percent change in quantity is bigger than the percent change in price. And so what happens to quantity has the biggest effect on total revenue. And if demand is inelastic, if the percent change in quantity is less than the percent change in price, then what happens to price has the bigger effect. So I just wanted to illustrate that with this same example. In both cases, the price went from $10 up to $12. So that's a $2 increase in price. $2 as a percentage of $10, so it's a 20% increase in price. And we were at 500, and here quantity fell from 500 down to 300. It fell by 200 units. That's a 40% drop from 500. Whereas here, it only fell by 50 units, only a 10% drop. And so in this case, elasticity is the percent change in quantity, which is negative 40, over the percent change in price. Price went up by 20, quantity went down by 40. Elasticity is negative 2. What's happening to quantity is a lot bigger than what's happening to price. And so the loss from the decrease in quantity is bigger than the gain from the decrease in price. When demand is elastic, increasing price leads to a bigger decrease in quantity, and total revenue falls. And we can tell that when we see elasticity, if we have a number for elasticity, if that is bigger than 1 in absolute value, meaning again, ignore the negative sign, but if in sheer magnitude that's bigger than 1, that's saying what's happening to quantity is bigger than what's happening to price. And so if quantity is falling, your total revenue is falling. People are very responsive. You raise your price, you sell so much less that your revenue goes down. Whereas over here, you can see the elasticity, quantity falls, but it only falls by 10% with that 20% increase in price. And so elasticity is negative 1/2 or negative 0.5. I don't care if you use fractions or decimals, whichever you're more comfortable with. It's less than 1. What's happening to quantity is only half as big as what's happening to price. And so, yeah, you raise your price and you lose quantity, but you lose so much less quantity. Quantity is not very responsive. Demand is fairly inelastic, not very responsive. And so I raise my price and quantity doesn't fall very much at all. And so my total revenue goes up. So it's for whatever the given change in price is, the question is how big is the change in quantity relative to the change in price? If the percent change in quantity is bigger than the change in price, then what happens to quantity, is what happens to total revenue. If the percent change in quantity is smaller than the percent change in price, then what happens to price has the dominant effect on what's happening to total revenue. And again, you're never really going to calculate elasticities, but it's just important to sort of understand the concept of elasticity, understand that it can be measured and it can be calculated for you, and understand what that number means. And elasticity bigger than 1 in absolute value says demand's fairly responsive. Numerator is bigger than denominator. And so and specifically, an elasticity 2 says the percent change in quantity is twice as big as the percent change in price. That's pretty responsive. Here, the percent change in quantity is only half as big as the percent change in price. Another thing I want to point out here is that elasticity and slope aren't the same thing, because it's not just how quantity and price are changing, but what they're relative to, as we talked about when we talked about percentage changes. But you can see typically a flatter demand curve represents more elastic demand. A steeper demand curve represents somewhat less elastic demand, more inelastic demand. And you can see why. For the same change in price, we're getting a lot more change in quantity. For the same change in price here, we're getting a lot smaller change in quantity. So a steeper demand curve says as price changes, quantity is not changing all that much. Whereas for a flatter demand curve, as price changes, quantity changes a lot more. So again, it's not just the change, it's what they're relative to. So slope and elasticity aren't the same thing, but they are clearly related. Flatter curves represent relatively more responsiveness, quantity changing more. I didn't label my axes, QQ, PP. Always label your axes. Steep demand curves, really steep demand curves, quantity changing a lot less, demand a lot less elastic. So, so again, I'm not going to spend a lot of time on how to calculate elasticities, but you should, if you're given a percentage change in quantity, a percentage change in price, be able to calculate the elasticity. Or you should also, if I said something like, you hire an economist and they tell you that the elasticity of demand for your product is negative 0.8. And you should be able to interpret what that means. You should be able to say, if price increases 10%, what happens to quantity demanded? How much does it change and in what direction? Given this information, you should be able to figure that out. So take a second and try to calculate that on your own. If we know elasticity equals a percent change in quantity demanded with a percent change in price, and if we know elasticity is negative 0.8, and we know the percent change in quantity is 10, then we just solve that equation, right? And it gives us that if price is going up by 10, that's a positive number, then the percent change in quantity demanded, we just multiply each side through by 10, right? Multiply by 10 over here gives us the percent change in quantity, multiply by 10 here, and that gives us negative 8. So a 10% increase in price leads to an 8% decrease in quantity. And you should sort of just be able to see that looking at that, right? Because elasticity is the percent change in quantity relative to the percent change in price. If this equals negative 0.8, that's saying the numerator is only 0.8 times as big as the denominator. So if price is going up by 10, quantity is going down by 8%. So given this formula, given any of these numbers, you should be able to calculate elasticity like we did previously, or you should be able to, given an elasticity and given a percent change in price, be able to calculate how much that's going to change quantity. And then you can also look at this and say, what will happen to total revenue? If the elasticity is negative 0.8, you should be able to explain conceptually what happens to total revenue when price changes, given that this is the elasticity. So take a second and think about that. If I raise my price, what's going to happen to my total revenue? Will it increase or will it decrease? If I raise my price, what's happening to price is bigger than what's happening to quantity. So price increases 10%, and that leads to quantity decreasing by 8%. So the gain from the higher price is going to more than offset the loss from the lower quantity. Our total revenue will increase. What's happening to price is greater than what's happening to quantity. demand is inelastic, the absolute value of elasticity is less than 1. The percent change in quantity is smaller than the percent change in price. So if I raise my price, yeah, I'm going to sell less, but not so much less that I'm going to lose revenue. What I gain from that higher price is going to be more than enough to offset what I lose from selling a little bit less.